Hey everybody, it's Missy. We are doing our contours of curved sided shapes today. So last time we talked about contours, what they are. They're the flats or curves of a surface. So for example, on a cube, we have a bunch of flat sides. On a cylinder, however, we have a curved side that we can grab around like a soda can. So we're going to talk about how to draw the curves on curved contoured shapes. So first things first, what you're going to do is you're going to draw a cylinder, a cone, and a sphere. So we're going to do that by drawing a cylinder. Can I draw a nice cylinder that's not lopsided? That'd be great. Perfect. I'm going to come down. I'm going to come down. Make sure to get that bottom curve. What you'll end up with a lot of times on cylinders is kids will forget that the bottom isn't flat and they'll just draw it as a stiff line, which is not what we're looking for. You also want to make sure that that bottom curve matches the curve up here on the other side of that portion. We're going to have ourselves a little cone. We're going to draw kind of like so. Can I not draw lopsided? That would be great. It's because I have to draw from an angle at the side. All right, yes, I know it's my snack alarm. Snack alarm, leave me alone. I'll eat my snack later. I have to have an alarm to remind me, otherwise I won't remember to eat. It's terrible. I don't have enough of a snack response. All right. Remember, whenever you're drawing a sphere, that in order to draw a circle, don't just draw and erase, draw and erase, draw and erase. Make several lines until you know which ones you can get rid of, and then keep the ones that you want to keep. That way you'll end up with the nicest circle with the least amount of effort, because for whatever reason your brain gets stuck in a rut and tries to draw the same line repeatedly. No matter how many times you're like, that's not the right line. You got to have it in place for your brain to go, oh yeah, that's not the right place. All right, so we're going to start with our cylinder here. And on our cylinder, we do have one flat side. That is this one, which is our base. So we have one on the bottom and one on the top, but we don't see the one on the bottom because we're looking down at this shape. And unlike a cube or a rectangular prism, we don't have any sides that are parallel on this flat side to follow. So we're going to find our parallel lines that we need to make for this one by thinking about how we made a cone whenever we were drawing it in the first place. So in order to draw the, not the cone, whenever we're like drawing the top portion of a cone and drawing that line, we drew a line from the two furthest away points on our oval and connecting the two shortest together points on our oval. They look something like that. And just like before, we're gonna half and half and half and half. So we can't measure from this side. We have to measure along this line. So there's my halfway. So here's that. Here's my halfway. So here's that. Here's my halfway. So here's that. And it's going to look something like this. And so that is my contour for that flat side. It's all still parallel lines. Because it is parallel lines, this entire side would be shaded as one shade of gray when we get to how to shade these. However, this side is not all parallel lines. There are a few parallel lines. You'll see that either side right here on the right and the left, those are parallel to each other. So the lines that follow that direction on our contour are going to be parallel. Nothing weird or wonkus about that. We're gonna have our in half, our in half, and our in half. But this side and this side are not. This bottom edge right here and this top edge right here are curved. It is a curving contour. And so what the line that's going across here is also curved. In this particular case, it's going to match this same one. So this right here was the first one we drew. This one right here matches this one. All the ones in between should also match. A tip. Usually the section in the center is a little bit less curved, while the section on either side curve a little bit more. So I'm gonna have my section at the center that curves a little less, and then it curves a little more, curves a little more. Same one's gonna go here in half again, and same one's gonna go here in half again. Now, because this contoured grid has curves in it, we know it is a curved shape, and therefore we know one more thing. Curved sides are shaded as a gradient. If you're not sure what a gradient is, basically think like so. That is a gradient of light to dark. On a colored object, it might look more like so, but it is a transition of one color smoothly into a different color or value. All right, so we know that that one is gonna have those curves there. Now we're gonna look at our cone. Our cone also has a flat base, like so, except in this case, we don't see it, so we don't draw it. We only have the curved face that we're looking at right now. Now, that said, we do not have any parallel lines on this one. There are no parallel lines on this particular piece. I keep deciding, like, no, I want a different color. Instead, what we have are lines that are coming up from the side, and they're all meeting at a point. And so what we're gonna do here is exactly like what we did with a pyramid. We're gonna have lines that fan out from the point where our sides meet to our base. Now, from here, we have this bottom edge and we have a top point. We cannot make a line that matches a point because a point is not a line, but we do have this line down here. We can match our curve there. Just like we did here, we matched this curve to this bottom, we can do the same over here. Except, as our sides get closer and closer together, we cannot make the same size curve. It's going to get smaller to match. So over here, I have my curve. It's the same one, but you'll see it's smaller. It doesn't come all the way out to here. If I tried to make a curve that came all the way out, it wouldn't curve in the right place. It'd start to be more flat. So as we come up and we make our curves, they should stay nice and curved all the way around, matching this one at the bottom, because if we didn't, and we only curved it the same distance, this one would be very flat and it wouldn't curve until way out here. So that one's wrong, that one's wrong, the greens are correct. Cha-cha. So keep that in mind. Now, our last one is our sphere. There are no flat sides on here. We have no parallel lines to lead us. So we have to do some investigation thinking. Now, I know of a sphere that we all have grid lines all over. It happens to be the globe. So you're gonna think about this like a round planet Earth. And the first line I want you to draw is the line that is from the North Pole to the South Pole. I forget if this is longitude or latitude, but it is one of them. We're gonna have that line right there. We're also gonna draw our equator line that goes straight through the middle horizontally. Can I draw a straight line? That'd be great. Can I do it? Yes, I can. Magical. You're always gonna start your spheres like so. From here, there are two different methods that you can use. The top and bottom method will be the same for both. It's the second part that will be a little different between them. So for the one that will be the same for both, it has to do with our North and South Pole. The lines on the grid that surround the Earth, the longitude and latitude lines, all of the lines that go from the North Pole to the South Pole all converge at the North Pole and the South Pole. So you're gonna do the same thing over here, North Pole, South Pole. We're gonna have lines that bend around the Earth, and then they're gonna bend a little further. We're gonna bend around the Earth, and then we're gonna bend a little further. And it's gonna look a little bit like a crazy looking cat eyeball. Now, here's where they're gonna start looking different. The first one will always work, and it might be a little bit easier for you to remember because it is a little bit simpler, which is do the exact same thing that we just did, only sideways. We're gonna bend out a little bit, and then we're gonna bend out a little more, meeting east and west, bend out a little bit, and bend out even more, connecting east and west. This works on paper 99% of the time. However, it does not always translate to if you had to draw it onto an actual physical sphere. So this one might not work for you. You might look at this and be like, yeah, it kind of works, but it kind of doesn't. I prefer the second method. So if that one works for you, awesome. It will always work on paper. If you have to look at a physical sphere though, this one will not work. You'll want it to look more like the actual grid that we have on planet Earth. So as I said, on planet Earth, we do have the equator line always forever. We do have lines that go north and south and connect every time. Bam, 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 bam. Nothing about this has changed. However, on planet Earth, whenever we think about those longitude and latitude lines, the ones going east-west along our equator, those ones are parallel lines. They never touch. So we need to draw them curving around our sphere, but also being spaced apart. So we're gonna do the same sort of curving, but instead of having them end here and here, we're gonna raise them in steps. So we're gonna have a slight curve, a little bit more curve, and a lot more curve. A slight curve, a little more curve, and a little along here. But you can see that there's a little gap between these lines on the side. That one's a little bit sloppy, it's super uneven. That's a little better. So we can do it like this, and this one actually can be drawn on a physical sphere that's in front of us and can be very useful that way. All right, so the next set of notes should be on how to get the different shadows on these grids so that you can figure out what's what. All right, that's everything. Bye.
Woohoo.